Middle School Science, Newton's Laws of Motion 1 and 2 lesson. There's no doubt from Corey's face that he loves skateboarding. Corey and his friends visit Newton's skate park every chance they get. They may not know it, but while they're having fun on their skateboards, they're actually applying science concepts such as forces and motion, starting and stopping. Did you ever ride a skateboard? Even if you haven't, you probably know that to start a skateboard rolling over a level surface, you need to push off with one foot against the ground. That's what Corey's friend Nina is doing in this picture. Do you know how to stop a skateboard once it starts rolling? Look how Nina's friend Laura does it in this figure. She steps down on the back of the skateboard so it scrapes on the pavement. This creates friction, which then stops the skateboard. Even if Laura didn't try to stop the skateboard, it would stop sooner or later. That's because there's also friction between the wheels and the pavement. Friction is a force that counters all kinds of motion. It occurs whenever two surfaces come into contact. Newton's first law. If you understand how a skateboard starts and stops, then you already know something about Newton's first law of motion. This was developed by the English scientist Sir Isaac Newton around 1700. Newton was one of the greatest minds of all time. He developed 3 laws of motion and the law of gravity, among many other contributions. Newton's first law of motion states that an object at rest will remain at rest, and an object in motion will stay in motion unless it's acted upon by an unbalanced force. Without an unbalanced force, a moving object will not only keep moving, but its speed and direction will also remain the same. Newton's first law of motion is often called the law of inertia, because inertia is the tendency of an object to resist a change in its motion. If an object is already at rest, inertia wants to keep it at rest. If an object is already in motion, inertia will keep it moving. So, how does Nina use Newton's first law to start her skateboard rolling? Well, the skateboard won't move unless Nina pushes off from the pavement with one foot. The force she applies when she pushes off is a stronger force than the force of friction that opposes the skateboard's motion. As a result, the force on the skateboard is unbalanced and the skateboard will move forward. Okay, well, how does Nina use Newton's first law to stop her skateboard? Well, once the skateboard starts moving, it'll just keep moving at the same speed in the same direction until another unbalanced force acts on it. That force is the force of friction between the skateboard and the pavement. The force of friction is unbalanced because Nina is no longer pushing with her foot to keep the skateboard moving. That's why the skateboard will stop. Changing direction. Corey's friend Jared likes to skate on the flat banks at Newton's skate park. That's Jared in this figure. He reaches the top of the bank and he turns his skateboard to go back down. To change direction, he presses down with his heels on the edge of the skateboard. This causes the skateboard to turn in the opposite direction. So let's think about how Jared is using Newton's first law of motion to change the direction of his skateboard. Well, by pressing down on just one side of the skateboard, it creates an unbalanced force. The unbalanced force causes the skateboard to turn towards the other side. In the picture, Jared is pressing down with his heels so the skateboard turns toward his toes. These boys are racing around the track at Newton's skate park. The boy who can increase his speed the most will win the race. Tony, who is the closest to the camera in this picture, is bigger and stronger than the other 2 boys, so he can apply greater force to his skates. So does that mean that Tony will win the race? Not necessarily, because force isn't the only factor that affects acceleration. Force, mass, and acceleration. Whenever an object speeds up, slows down, or changes direction, it accelerates. Acceleration occurs when an unbalanced force acts on an object. 2 factors that affect acceleration of an object are net force acting on the object and the object's mass. Newton's second law of motion describes how force and mass affect acceleration. The law states that acceleration of an object equals the net force acting on the object divided by the object's mass. And then this can be represented by the following equation. Acceleration equals net force divided by mass, or A equals F divided by M. While Tony races along on his rollerblades, what is the net force acting on the skates? Well, Tony exerts a backwards force against the ground, as you can see in the figure here, first with one skate and then with the other. This force pushes him forward. Although friction partly counters the forward motion of the skates, it is weaker than the force that Tony exerts. Therefore, his net, or total force, is forward. Direct and inverse relationships. Newton's second law shows that there is a direct relationship between force and acceleration. The greater the force applied to an object of a given mass, the more the object will accelerate. For example, if you double the force on an object, it doubles its acceleration. The relationship between mass and acceleration is different. It's an inverse relationship. In an inverse relationship, when one variable increases, the other decreases. The greater the mass of an object, the less it will accelerate when a given force is applied. For example, doubling the mass of an object will result in only half as much acceleration for the same amount of force. Question: Tony has a greater mass than the other two boys that he's racing. How will this affect his acceleration around the track? Well, if Tony's mass is greater, that will result in less acceleration for the same amount of force. Summary: Newton's first law of motion states that an object at rest will remain at rest, and an object in motion will remain in motion unless acted upon by an unbalanced force. Using unbalanced forces to control motion of a skateboard demonstrates Newton's first law. Newton's second law of motion states that the acceleration of an object equals the net force acting on the object divided by the object's mass. According to the second law, there is a direct relationship between force and acceleration, and an inverse relationship between mass and acceleration.